In question 14, the reactivity or series of a metal are given below, which contain both familiar and unfamiliar metal. Like some of the metals you have studied before, you know about their reactivity and the position, and some of them are unfamiliar to you. For the most of unfamiliar element, which are marked with a steric, their common oxidation states are also given to you, like barium, lanthanum, chromium, palladium. You have to choose a metal from the above list to answer the following. Which two metal would not react with a dilute hydrochloric acid? So first, when we set up our normal reactivity series, according to the reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver. So till here, like elements which are above copper are usually react with acid. Below copper does not react with acid. So you have to select the metal which are does not react, would not react. So it means we know like copper and below cannot react. So it means those which are above can react, but those which are below cannot react with dilute acid. So one is copper, another one is palladium. So we use our normal reactivity and work out the position for elements which can react. You can write the symbol. Copper is Cu and palladium is Pd. The next one, which of two unfamiliar metal will react with cold water? So first, look how to work out this. First, we find which, first we'll try to figure out which of the metal can react with cold water. So we have potassium, sodium, calcium, then magnesium, aluminum, zinc, iron, lead, copper, mercury, silver. So these three metals, they can easily react with cold water. So means those metals which are above magnesium can react with the cold water. So when you check this, so this is our magnesium. So metals which are like magnesium and below can react with steam, but metals which are above magnesium can react with the cold water. So which of them can react with the cold water? That is barium and lanthanum. Is it clear how we work out this? Which two can react with?
Yes, sir, clear.
So just identify the position, the barrier, and then work out what is the oxidation state of a barium. You have to use a periodic table for that. Barium is a group 2 element, so +2 or 2 plus. Yeah, +2 or 2 plus, you can also say. Then name an unfamiliar metal whose oxide cannot be reduced by carbon. So how to work out this? See, we'll work out the position. Again, our reactivity, normal reactivity, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver. Now, what is the position of carbon? The carbon is between aluminum and zinc. Means elements which are below, like zinc and below, can be reduced. Their oxide can be reduced by the carbon. So the question is, name an unfamiliar whose oxide cannot be. So it cannot be chromium or palladium because These metals should be more like what is the position of a carbon? Carbon is between aluminum and zinc. So here we will have a carbon. All these oxides, like if we have zinc oxide, chromium oxide, iron oxide, carbon can remove them. But the metals here above the carbon, it cannot remove. So any unfamiliar, so you can mention barium or you can mention lanthanum. But don't mention chromium or palladium. That will be wrong. Is it clear, this one?
Yes, sir, clear.
And the last one is a transition metal or a D block element. Like what should be able to predict from a metal such as iron that they have more than, like their transition metals, whenever it's having a more than variable oxidation state, we call their transition. So this question we solve by using the same idea of the reactivity of the metals, which we are familiar of. Yeah, that why they have a colored compounds, we'll say that because they are transition element, or why they have a variable oxidation state. Actually, there's a reason behind that, but you don't, like in IGCSE, you don't go deep inside like why it happened. That's why you just mention the baseline answer, which is that they're transition element. But practically, there is a reason for that, that why they have variable oxidation state. A question 15, a major use of a zinc blend, a byproduct of extraction of a zinc from ore is sulfur dioxide, which is used to make sulfuric acid. Zinc blend is heated in air. Zinc oxide and sulfur dioxide are formed. Right equation. Plus oxygen, zinc oxide plus, because it's roasted in air. And the equation must be balanced as well. 1 mark is for writing the equation, 1 mark is for the balancing. So we start balancing. You can memorize, learn this because it is always a fixed 2, 3, 2, 2. Zinc oxide is reduced to zinc by heating with carbon. Name other two reagent which could be used to reduce zinc oxide. Like we can name any metal, we can name any other substance. So we have the reactivity: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, platinum. Carbon is between aluminum and zinc. So what else? Carbon is one of them. What else? Magnesium, potassium, calcium, any more reactive metal. Like any metal which is more reactive than zinc can remove the oxide from zinc. Like example, if zinc oxide react with magnesium, so magnesium is more reactive, it will displace. So as a result, it will produce magnesium oxide plus zinc. The zinc obtained is impure and it's a mixture of metal. Explain how fraction distillation could separate this mixture. The boiling point of a zinc is 908, cadmium is 765, and lead is 1751. Like this extraction is producing variety of metals. You just have to mention how the fraction distillate, because they have different boiling point. So they will boil at different temperatures. So first the cadmium will distill off. So every metal boil at different temperature or boil at its boiling point. That is 1 mark. The smaller boiling point, the substance will distill off first. That's right. So cadmium, then zinc, and then third one. Second mark is for mentioning the order of the distillation. Like 1 mark is for mentioning they have different boiling point. So metal separated on the basis of their boiling points, and cadmium distill off first, then followed by zinc, and at the last lead. Question 16. The reactivity series shows a metal in order of the reactivity. Always remember, the more reactive metal turn into ion, and the less reactive ion turn into less reactive metal ion turn into an atom. Zinc is more reactive than lead. From this we establish. So which is above zinc? Like you have to write another metal which is above zinc. Above zinc is aluminium. And what is the equation for aluminium? Plus 3, or 3 plus and 3 electrons. Yeah. Because we have to here, like it's actually a reactivity series is given. So we want, even you write calcium, you write potassium, you write sodium, they all are correct because we want any of them above or more reactive than zinc. The next one, in a space at the top of a list, write an ionic equation that we did. Write an ionic equation for reaction between aqueous silver nitrate and zinc. Like when zinc is reacting with silver nitrate. So just a minute. No, that is not right. This is not correct. Why this is not correct? Because we want to write an ionic equation for reaction between silver nitrate and zinc. In ionic equation, we don't write the spectator ion. First, I'll write the full equation and then I'll explain what will be an ionic equation for that. So first we write a full equation between silver 1 nitrate and zinc. So silver 1 nitrate is AgNO3 and zinc is Zn. Zinc is more reactive. So zinc is more reactive than silver, as you can see in the reactivity. It will form zinc nitrate. So the formula of zinc nitrate will be Zn NO3 in a bracket 2 plus a silver metal will be produced. And to balance the equation must be balanced. So we have 2 nitrate ions, so we put 2 silver, and this is equation is balanced now. Now, this is the overall equation, but they did not ask for overall equation. They are asking for ionic equation. In ionic equation, what we do, like this solid, liquid, and gas, we write as it is. Like, so zinc is solid, all nitrates are solubles, aqueous, zinc nitrate also aqueous, and this is solid. Then we cancel out the common ion in aqueous. So nitrate ions cancel out in both. So what is an ionic equation for that? Zinc reacted with 2 silver ions in the solution. As a result, it will form zinc ion because a more reactive metal turn into an ion and produce zinc atoms. So, sorry, silver atom. So less reactive ions will change into atom. More reactive atom will change into ion. This is an ionic equation. This is a full symbolic equation. So how to construct an ionic equation? You just need, even with this information, you can construct an ionic equation as well. Like, I know zinc is more reactive and it is reacting with silver solution or a silver ion. So when they react, the zinc will turn into an ion and silver will turn into an atom. And then balance the equation, because if zinc is losing 2 electrons, silver should gain 2 electrons. So that's why this should be 2 here and 2. Because the ratio of the charge should be balanced. The charge is 2 plus 1, like total 2 here. On the left hand side, 2 should be on the right hand side. So you can construct any ionic equation between the two metals. The second one, why the positive ions are likely to be oxidant or oxidizing agent. By oxidizing agents, they reduce. And what is the meaning of a reduction? Reduction means they gain electron. No, oxidizing agent itself, it is reduced, and reduction is a gain of electron, not loss. They lose to, no, you have to mention that they not lose electron, they gain electron. The question is why the positive ions are likely to be oxidant. Why they're likely to be oxidant? They're asking about positive ions, not metal, positive ions. Why positive ions are likely to be oxidant? Because positive ion can gain the electron back. And remember one thing, the definition of reductant or reducing agent is same as oxidation, which is a loss of electron. And the definition of oxidant or oxidizing agent is as reduction, which is a gain of electron. So why the positive ions likely to be oxidant? Or because they can gain electron. Which is the best oxidant? Which one can gain electron easily? So that is silver ion. Because less reactive metal ion can take their electron back easily as compared to more reactive metal ion. Write an ionic equation. Which ion in the list can oxidize a lead metal? So whenever you have a reactivity, remember one thing. If the metal is more reactive, which reaction is feasible? The forward reaction is feasible. Like zinc can easily lose electron, turn into zinc ion. But if we have less reactive metal, which reaction is feasible? The other way around. Like, because they are not highly reactive, their atom cannot lose electron, but their ions can gain their electron back and turn into an atom. So for more reactive atoms, remember one thing, the more reactive the atom changes to ions. And for less reactive, the ions can easily change to atoms. And when atom changes to ion, they lose electron. When ions turn into an atom, they gain electron for the metals. The next one, which ions in the list can oxidize a lead metal? Like, which one can react with lead? So it can be copper or it can be silver, any of them. Because when lead metal react with copper ion, it will turn into lead ion and copper metal. So copper is reduced, lead is oxidized. So when reduction happens, this is an oxidizing agent. So which ion can easily oxidize? So copper ion can easily oxidize the lead. They ask for the ion, so we don't have to mention for atom, we have to circle for the ions. If you say zinc won't react with lead atom, zinc will react with lead ion. Because a more reactive atom can react with less reactive metal ion. Is it clear discussion?
Yes, sir, clear.
Any doubt? The next one is extraction of a zinc. Describe the extraction of a zinc and it's of 5 marks. So how you score the 5 marks? 1 mark. You can use screen annotation or a chat. First is by zinc sulfide is heated or burned in air. That will give you 1 mark. Zinc sulfide, zinc blend is crushed and added to water, so impurities sink. Yeah, that is the first thing you mentioned, but then what happened? Like 1 mark is for the equation. The first equation, 1 mark is for the second. There's another equation in which you react Zinc sulfides came off from the top. Okay. Then zinc sulfide react with oxygen to give zinc oxide. Then zinc oxide heated with coke or a carbon. Carbon react with oxygen, give carbon dioxide. Carbon dioxide react with more carbon, give carbon monoxide. This is also correct. This is also right sequence. Yeah, this is correct. State two uses of the zinc. Where we use zinc. What are the uses of the zinc metal? We use to make an alloy brass. What else? Galvanizing, preventing rusting, galvanizing. Galvanizing is usually a term for zinc plating. So galvanizing is a preventing rust here. You can mention in galvanizing or making a brass or alloy. Even batteries are also used. Galvanizing iron. Batteries are also used. Consist of zinc electrodes. Question 18, a similar question. Just quickly, you can use screen annotation to complete this as well. Describe how zinc blend is changes into zinc oxide. How it is done? By strong heating in air or in furnace. Equation for zinc oxide to carbon react with reduction. How zinc oxide react with carbon? The equation for that. Write an equation for reduction of a zinc oxide by carbon. So zinc oxide plus carbon gives zinc plus carbon monoxide, or you can also form carbon dioxide. Yeah, it's fine. Both are correct. Carbon di, carbon mono, both are correct. The last one, the boiling point of a lead is 1007, zinc is 9. Explain why. When both oxides are reduced, only lead remain in the furnace. So temperature is above the boiling point of a zinc, so zinc vaporized. Boiling point of a furnace is above the boiling point of a lead is above the furnace. That's also correct. Major use of a zinc to make die casting alloys basically contain 4% aluminium and other strong and less malleable than pure. Other large scale galvanizing describe a structure of a typical metal such as zinc and explain why it is malleable. What is the structure of a metal? You can use your mic, you can use the chat, or you can use screen annotation to answer this. Metal, positive ion in the mobile or the sea of electrons, held together by a strong force, and layers can slide over each other. That's right. The particles in a layer can slide over each other without breaking. if you write only not brittle, because they ask for explain, so you have to why it is. So you have to state a reason here. The two arrows you can see a zinc atom turn into a zinc ion. So atom change to ion. What is this first change? Oxidation or reduction?
Oxidation.
Oxidation. And what about lead ion turn into lead atom? That is reduction. So which change is a reduction? That is change 2. And why it is a reduction? Because reduction means it is a gain of electron. And then we have to write an ionic equation for reaction between zinc and silver 1 ion. So zinc is more reactive, it will turn into an ion and silver atom will be formed. The equation must be balanced in terms of charge both sides. So that's how it is balanced. Charge and atoms. This is the same question. If you decrease in oxidation state, yeah, that's also correct. But whenever you write a definition of reduction or oxidation or oxidizing agent or reducing agent, better use the term electrons. Because usually in the marking scheme, they give the weightage for the electrons. It's not wrong. I'm not saying it's wrong. I'm just saying like use the term electron. Zinc is +2. So you have to remember the zinc oxidation state. Again, a similar question as we did in the previous one. In the following ionic equation of a metal in a space top of this, which is more reactive than zinc, that write that ionic equation. Yeah, that's right. You can mention potassium as well. That's right. You can mention, so any more reactive metal than zinc can be in this list. The next one, define oxidation in terms of electron. What is the definition of oxidation? Loss of electrons. Why positive ions are likely to be oxidizing agent? What is the definition of oxidizing agent? That is same as reduction. What is the definition of a reduction? So why positive ions likely to be oxidizing agent? Because they can gain electron. As they gain electron, yeah, they gain electron or can gain electron. Which positive ion can oxidize mercury? Like which is less reactive than mercury, you have to identify from the list. Mercury, this Hg, which is less reactive than mercury. So silver ion, always remember the more reactive, like less reactive positive ions can easily use as an oxidizing agent. Yeah, that's right. So silver, but you have to mention silver ion rather than silver atom, silver ion. Question 20 is again related to zinc. Lot of questions related to zinc. Given like the first one is dilute sulfur dioxide. Actually, this part give another use of sulfur dioxide. It's not in a new syllabus. You don't find sulfur as a topic. So sulfur dioxide is used to for a bleaching a wooden pulp, making sulfuric acid, or even it is also used as a preservative. How sulfur dioxide is converted to sulfur trioxide? That is, you have to remember as a reversible reaction rather than this whole process. So sulfur dioxide reacted with oxygen to give sulfur trioxide. The wooden pulp, for a paper making, for paper making, the extract is from the wood, and that extract from the wood is called a wooden pulp. So we used to bleach the wooden pulp, like removing the color. That's why the paper appear to be white. That's first it is bleached. So sulfur dioxide reacted with oxygen. What are the reaction conditions? 450, 2 to 3 atm temperature, and catalyst vanadium pentoxide. Fertilizers are basically compound which can produce nitrogen, provide NPK, nitrogen So name a fertilizer from sulfuric acid. So fertilizer from sulfuric acid. Yes, you have to learn the conversion of a sulfur dioxide to sulfur trioxide. That you have to learn, but not the uses of sulfur dioxide. So we can produce ammonium sulfate. So ammonium sulfate will be NH4 in a bracket 2SO4. Urea, if you mention urea is actually not directly from sulfuric acid. Sulfuric acid gives sulfate salt. So we have to mention like ammonium sulfate, or we can mention potassium sulfate. Some of the zinc oxide was mixed with an excess of carbon and heated around 1000. A zinc distill of. Name the two changes stayed in a distillation, boiling and condensation. What is a necessary? Why it is necessary to use excess of carbon? Like why we should use more than enough carbon to provide? No. Like here you can identify from this to ensure all zinc get oxidized. To make sure all the zinc oxidized, because what will happen like zinc not oxidized, to ensure that all the zinc is reduced, because it's not oxidation, it is reduction. Zinc oxide turned into zinc. Question 21. Steel is an alloy which is made from impure iron. Both iron and steel rust. The formula of the rust is shown. Name two substances that must be present for a rusting to happen or occur. Oxygen and water. Painting and coat with a grease or other. Painting and coating with grease are two methods. Give two other methods to prevent rusting. Sacrificial protection or galvanizing, or you can use copper plating, galvanizing with zinc, that is one, or copper plating, cathodic protection. Like you can also coat with copper, it will also prevent it from rusting. So coat with copper, coat with zinc, you will get 2 marks. One is either you coat with copper, but coating with copper, if it's scratched, it will start to rust. Name a reagent that can reduce the zinc iron oxide, iron 3 oxide to iron. Name a reagent that can reduce iron 3 oxide to iron. What substance we use? So usually we use carbon monoxide. Because we want to remove, we use carbon monoxide for them.
Sir, can it be with higher metal in reactivity?
Yes, you can mention that as well. Potassium or any other. Then write the symbol iron 3 oxide plus carbon gives 2 iron plus 3 carbon dioxide. Calculate the mass of 1 mole. Like mass of 1 mole means like we need the total mass of this. So for this we have to use a periodic table. Fe2O3.2H2O. So the question is you have to find Fe2O3 dot 3H dot 2H2O, I guess. Yeah, 2H2. So iron is 56 times 2 plus oxygen is 16 times how many oxygen are there? 3 here and 2. 3 plus 2 makes 5 because this total 3 and this 2. 5 plus hydrogen is 1. And how many hydrogen are there? 1 multiplied by 2 multiplied by 2, 4. So 1 into 4. So 56, this make 112, 80. So this will be 192 plus 4, 196. So the total mass will be equal to 196. Can we say in two steel article at the cathode? Yeah, that is right. Then we need, you don't have to write a formula here. Like the mass of iron in the compound, it will be 56 times 2, so 112 divided by 196 into 100. Yeah, that's right. It's fine. Like if you're writing, this will give you the percentage, like how much iron divided by total mass into 100. The next one, how addition of oxygen remove the carbon. So what actually happened when we are converting iron into steel? So carbon react with oxygen, leave carbon dioxide. And how addition of oxygen and calcium oxide remove the silicon.
It will form calcium silicate.
Or we can also say slag. So silicon react with oxygen to give silicon oxide, and then silicon oxide react with calcium oxide to form slag. So these are the questions from exercise metal. Here carbon react with oxygen, give carbon dioxide. So it reduces the amount. So remaining like from 22 till 26. So remaining like next few, tomorrow we'll do more questions from this exercise and try to complete this, as it's one of the important topics.